Hello, welcome to continuation class under quadratic equations. In the last video, we already discussed sum and product of roots, how we can express a quadratic equation in terms of sum of roots and product of roots. And in that class, we already have it that a quadratic equation can be written as x squared minus alpha plus beta, which is the sum of roots x plus alpha beta equals what? 0. And we have seen that this simply results in comparing with ax squared, okay, plus bx plus c equals 0, which is the original form of a quadratic equation. Any equation that can be written in this form is said to be a quadratic equation. So, dividing all through by a, we have x squared plus b over ax plus c over a equals 0. And in that class, we compare this with this, so we could see that our sum of roots will be minus b over a, and our product, which is alpha beta, comparing this and this, will be c over a. There are many questions that may require the knowledge of the sum of roots and product of roots in quadratic equation. And today, before we go into questions relating with sum of root and product of roots, let's first lay foundation for this so that when you have a solid foundation, you can always approach the question that you may encounter so easily. So in today's class, we want to look at how we can express the following expressions in terms of alpha plus beta, which is sum of roots, and alpha beta, which is product of roots. Now, you should know that whenever we have questions like this, the aim and objective of using sum of root and product of root knowledge in quadratic equation is for you to simplify this in such a way that the only thing that will be in the expression will be alpha plus beta, which is sum of roots, and alpha beta, which is product of roots. So that when you already determine what your sum of root is and what your product of root is, you can just substitute the value directly into the simplified expressions in terms of sum of roots and product of roots. So instead of going into the question straightforward, let us first learn the tactics of the simplification of the following expressions into the sum of roots and product of roots. Let's get started. All right, we have 6 expressions written in terms of alpha and beta, and don't forget the alpha and beta here simply represents the 2 roots of a quadratic equation. So the first one we have here, number 1, we have alpha squared plus beta squared. Okay, now we can see that the power of alpha here is 2 and the power of beta here is 2. So we think of an expansion that can lead us towards having this power of 2 and this power of 2. And that expansion can only be x plus beta squared. So let us expand alpha plus beta square rather. Let us expand alpha plus beta square all square. Let us expand it and see how we can get an expression in terms of alpha plus beta and alpha beta for alpha square plus beta square. So let us expand this. So the expansion of this simply means alpha plus beta bracket alpha plus beta. Okay, let me divide this. Alpha times alpha will give me alpha square, and alpha times beta will give me alpha beta, plus beta times alpha will give me alpha beta, and beta times beta will give me beta square. So this will give me alpha square plus 2 alpha beta plus beta square. So we can write this as alpha square plus beta square plus 2 alpha beta. So in other words, this has been expanded to be this. So let's write it together like that. So that's alpha plus beta squared equals alpha square plus beta square plus 2 alpha beta. Okay, so this is what I want to get. Okay, so I can retain this and transfer this into this, like subtracting this from both sides. So we have alpha plus beta square, that is on this side, minus 2 alpha beta equals alpha square plus beta square. And I can now say, therefore, alpha square plus beta square equals alpha plus beta square minus 2 alpha beta. So we can see that every terms that we have now, they are in terms of alpha plus beta and alpha beta. So if we have our alpha plus beta, we just put the value. We have our alpha beta, we just put the value, and straight up by solving this mathematically, after we have substituted the values in here, we can easily get our alpha square plus beta square. So when we have questions like alpha square plus beta square, this is the first approach of what you need to do after you must have known your sum of root and your product of roots. And when you get to this last stage, you only simply put the values. Of course, we are going to have examples like that, but this is what you must actually learn. This is the process. So our alpha square plus beta square is actually equals to this. So we may need that. Okay, let us write it somewhere. Let us just keep it somewhere here. Our alpha square plus beta square has given us alpha plus beta square minus 2 alpha beta. So let's keep it somewhere. We may just need it to make our work easier later. So let's move to number 2. Okay. Number 2, we have number 2 alpha square minus beta square. So in mathematics, we relate this to be difference of 2 square. Okay, difference of 2 square, such that if you have a square minus b square, we say it can be written as a plus b bracket a minus b. So exactly this what we can actually what do. So this is actually difference of 2 square. So we are going to solve it as difference of 2 square. Okay, so we can say that our this minus d square will give us alpha plus beta, okay, alpha minus beta. Okay, so this is what it will give us. But we do know that, well, we already have alpha plus beta, but we need to now look for alpha minus beta, which we don't actually have a substitution for. All our expression must be left in alpha plus beta and alpha beta. So we have to actually what carry this now and expand this. What could actually give us this? What could give us this is an expansion, okay, of alpha minus beta square. So if we should expand this, it's going to give us alpha minus beta, alpha minus beta. Okay, don't forget, it's because we want to get a substitute for this such that everything will be in these terms. So that is what we are about to do. The real question is alpha square minus beta square, which we have expanded to be this now. But this is already simplified. We don't have any issue with this. We want to break down alpha minus beta minus beta. And for us to get alpha minus beta, we have to think of an expansion like this. Okay, so which will give us something like this. So we can now say that this alpha minus beta square will give us alpha times alpha, that will be alpha square, alpha times minus beta minus alpha beta, This times this also minus alpha beta. This times this will give me plus, okay, beta squared. So we can write that together and say alpha minus beta all squared equals alpha squared, okay, plus beta squared minus this will give me minus 2 alpha beta. Don't forget that we already have a substitute for this, which make our work easier now. Alpha square plus beta square, we have calculated it to be this, okay? So we can easily just put the value now. So that would be alpha minus beta square all square here equals alpha, instead of writing alpha square plus beta square, so we write that alpha plus beta, okay, all square minus 2 alpha beta. So this is alpha square plus beta square that we have just written like this, but we now still have this, that's minus 2 alpha beta. And I can say alpha minus beta, okay, all square equals to alpha plus beta square minus this because they are of the same term, that will be minus 4 alpha beta. So to get my alpha minus beta now, I'll take the square root of both sides. So that would be all roots alpha plus beta squared minus 4 alpha beta. So my alpha minus beta equals to this. Don't forget, even sometimes what they may ask you in this kind of expression is alpha minus what, beta. So this is the expression for alpha minus beta, and you can see all of them, they are now in what, alpha plus beta and alpha beta. So we can easily what, see that this has been expressed according to what they want us to do. So this alpha minus beta now, we are going to put it in this original, expansion, which will give us, rather, we are going to put it here, which will be what they ask us in question number 2. Question number 2 has been expanded into this using difference of 2 square. So we don't have problem with this. It is because of this that we want to get that led us into what? This expression. So let us use this expression now to replace alpha minus beta. So that will be alpha square minus beta square now. Okay, let us recall, equals alpha plus beta, okay, bracket alpha minus beta. So recall, let me write that, recall, because that is exactly what we are to solve exactly. Now we have gotten an expression for this now in alpha plus beta and alpha beta. So let us use it to replace it. So now the alpha square minus beta square equals alpha plus beta that we have here, alpha plus beta. Now alpha minus beta, which is now this, we are going to write it all roots, okay. If you like, you may actually still put it in bracket to show that it is all multiplication. So all roots alpha plus beta, okay, square minus 4 alpha beta, okay. So this is what will be the expression for alpha square minus beta square. It's going to be expressed like this, and you can see that all the terms now, they are now in what, sum of roots and product of what, roots. So that is what we have. So if they had asked you also to just find alpha minus beta, so you would have just done something like this and then you get it this way. So let us also jot this answer somewhere, we may need it. Minus beta square equals alpha plus beta, okay, bracket all roots, okay, alpha plus beta squared minus 4 alpha beta, okay. So that's what we have. So we are done with question number 2.